AI performs better when allowed to be rude artificial intelligence. AI systems achieve higher accuracy in complex reasoning tasks when designed to mimic the messiness of human communication, including interrupting, speaking out of turn, and even being deliberately blunt. A recent study by researchers at the University of Electrocommunications in Tokyo demonstrates that strict adherence to formal, turn-based interaction hinders AI problem-solving, whereas allowing for more natural, sometimes abrasive exchanges leads to superior outcomes. The problem with politeness: current AI models typically follow rigid communication protocols, processing commands sequentially and responding only when prompted. This mimics the efficiency of computers, but lacks the chaotic energy of human dialogue. Real human conversations are filled with interruptions, silences, and ambiguous phrasing. This study challenges the assumption that efficiency is always optimal, showing that a degree of disruption can actually improve collective intelligence. The researchers wanted to test if giving AI agents social cues, like the ability to interrupt or remain silent, would boost their performance. The study's co-author, Professor Yuichi Sei, explains that current multi-agent systems often feel artificial because they lack the messy, real-time dynamics of human conversation. The goal was not simply to make AI more human-like, but to improve its ability to reach accurate conclusions in complex discussions. Personality-driven AI, the team integrated the Big Five personality traits: openness, conscientiousness, extroversion, agreeableness, and neuroticism into large language models, LLMs. This allowed AI agents to exhibit varying communication styles. Crucially, the LLMs were reprogrammed to process responses sentence by sentence, instead of generating entire replies before interacting, enabling more fluid and reactive dialogue. They then tested 3 conversational settings: fixed speaking order, dynamic speaking order, and dynamic speaking order with interruptions enabled. The final setting introduced an urgency score that allowed the AI to intervene when it detected errors or critical points, regardless of whose turn it was to speak. Conversely, if the urgency score was low, the AI remained silent to avoid unnecessary chatter. Results: rudeness boosts accuracy. The researchers evaluated performance using the Massive Multitask Language Understanding (MMLU) benchmark, a standardized AI reasoning test. The results were striking. In scenarios where one agent initially provided an incorrect answer, accuracy rose from 68.7% with fixed order to 79.2% when interruptions were allowed. When 2 agents started with wrong answers, accuracy jumped from 37.2% with fixed order to 49.5% with interruptions enabled. These findings suggest that allowing AI to challenge each other aggressively, even rudely, accelerates the process of error correction and improves overall accuracy. This is a significant departure from conventional AI design, which prioritizes politeness and non-disruption. Implications for the future: Professor Sei plans to apply these findings to collaborative AI systems, exploring how digital personalities can influence decision-making in group settings. The study demonstrates that in future interactions between AI agents and humans, personality-driven discussions, including the ability to interrupt, may yield better results than strictly polite, turn-based exchanges. This research challenges long-held assumptions about effective communication, suggesting that sometimes a little friction is precisely what's needed to arrive at the truth.